Scientists ask many questions, but not all are scientific questions. A good way to tell if a question is a scientific question is to check if the answer would change based on who you asked. If the answer is no, you have a scientific question. A scientific question leads to an investigation or experiment. A hypothesis is a potential answer to a scientific question, which will require testing to see if it is correct. Start with open-ended questions that begin with how, why, or what. Narrow these broad questions down by adding testable criteria, which will require observing or measuring. Next, consider the variables that may impact the answer to your question. You will have to select independent and dependent variables as well as a control. The independent variable is what you will intentionally change during an experiment. You measure its effect using the dependent variable. Everything else should be constant, otherwise you can't be sure that the dependent variable changed because of the independent variable. One way to ensure this is with a control trial. This is where everything is present except the independent variable. With all other things being equal, the dependent variable must have responded or changed due to the independent variable. Combine these variables with your testable question and you've got it, the experiment that you're going to perform. Let's look at some examples. This isn't a scientific question because different people may answer it differently. This is better, but still somewhat subjective. You may know that water boils at different temperatures depending on how far above sea level you are. This is a scientific question, even though it's a little boring. We could do an experiment to answer this. Go to sea level, heat water until it boils, and measure the temperature. But let's say that yesterday you saw your dad buy loads of salt for the driveway. Even better, you just need to add some variables. The independent variable is the amount of salt. We measure its effect with the dependent variable, the boiling temperature of water. This is a great scientific question, but not one that you could use for your project. We could just look this answer up. Let's say that we do some research and find out that salt causes the boiling point of water to go up while making the freezing point go down. This principle explains why your dad was buying salt for the driveway. He wants to melt any ice that may form in the winter. Let's make this into an engineering project. Here is a great question written for an engineering project. We have an independent variable, which is the blend of salts, and a dependent variable, which is the freezing temperature. We also have engineering design criteria of being environmentally friendly. We could do some research and define even more criteria. Scientific questions may change during the scope of your project. Remember that the scientific method and the engineering and design process aren't a series of rigid steps to be done in order. Here are some tips for writing your scientific question. Focus on inquiry-type questions instead of demonstration-type questions. Your teacher does not want a demonstration of a principle that is already known. Look for ideas around you. What's going on in the news? Try some science websites. Have you seen anything lately that makes you wonder? These can all be the basis for great projects. Provide operational definitions for unclear terms. For example, if you say best, what exactly does that mean? Make sure your question has a quantifiable answer, meaning it can be measured and observed through experimentation using variables.